Okay, in this problem, there's a lot of words and there's a lot of numbers. So it's important to figure out what is our measurement. And a lot of these things here are relationships. For example, if we look in this, we can see that the first information about 1 gallon is that that's actually information of a relationship between gallons and how much carbon dioxide each gets. So that's those two numbers there are relationships. We also have relationship that um, 1 car drives 5,000 miles. So that is a relationship. And we also have 20 miles per gallon is the average. So those are relationships. So there's only one thing in here that's really a measurement about the number of cars, and that is our 40 million cars. So when we go to do this problem, since we have a lot of relationships, even though this is a little more complicated than a typical factor label, we can actually use factor label to solve this problem. So we would start with our 40 million cars out in front. I'm going to just kind of make up my own abbreviations for this. So we have 40 million cars to start with, and we can actually factor label our whole way through this problem. So that means that I need to have cars on the bottom, and I want to say, okay, well, what do I know about cars? Well, the question asks us how much carbon dioxide total is given off. So I need to basically get from cars to carbon dioxide. And I don't know much about that, but it does tell me that every year 1 car drives about 5,000 miles. And again, notice the line is over the 0, so we have 2 sig figs. The 1 car is an exact number, so that does not affect our sig figs. So that gives me a relationship that I know 40 million cars, we can figure out essentially how many miles have totally been driven. Well, of course, we're not done yet, so we need to keep going here, more factor label. I have miles as my unit out on top here, so automatically that's got to be my no-brainer step on the bottom to put miles as my unit down here, because that needs to cancel out. And then, well, what do I know about miles? Well, I know that every 20 miles that we drive consumes about 1 gallon of gasoline. Okay, because ultimately the question is asking me about carbon dioxide, and in order to get to carbon dioxide, I know the relationship between gasoline and carbon dioxide. So this will ultimately get me to that. So I know that is true. Again, we're not to where we need to get to yet, so we need to keep going. So another factor label here will help us out. Now again, I have gallons as my unit up on top, so no brainer, that needs to be the unit that goes on the bottom. So I've got to put, I'll abbreviate that. And I know this time that 1 gallon, now again, ultimately we're getting to carbon dioxide, so I know that 1 gallon produces 9.5 times 10 to the 6th milligrams of carbon dioxide. Now the question says how many kilograms is that? So we need to just get our answer now. Now we've done a lot of the hard part. Now we need to get this thing from grams into kilograms. So to do that, we need to make this a little smaller to get it to fit. So I've got it in the milligrams right now. So we're going to need to keep going. So I need milligrams as my unit on the bottom. I might not be too quick with milligrams to kilograms, so this is one of those prefix to prefix conversions, so stick with what you do know, stick with the base unit, and grams are bigger, so 1 gram is equal to 1,000 milligrams. That is true. Not quite done yet. Now I need grams to go to kilograms, and we can say that 1,000 grams is equal to 1 kilogram. Now looking at my setup here, I've got cars canceling out, I've got miles and miles canceling out, gallons cancel, milligrams cancel, grams cancel, so I am left with units of kilograms. And then all of my relationships, double check everything. One car drives 5,000 miles. Yep. In a year. Yep, that's true. 20 miles in 1 gallon. That's true. 1 gallon is 9.56 milligrams carbon dioxide. 1 gram is 1,000 milligrams. 1 kilogram is equal to 1,000 grams. So everything set up is correct. And if we punch this into our calculator, we should get an answer of 9.5 times 10 to the 10th. And then our unit here is kilograms. So 9.5 times 10 to the 10th is the correct answer. You can do this as just one big long factor label problem, set up real nicely and clearly. It's a beautiful thing.